Good morning and welcome to SCC's webinar about the LME7 burner flame safeguard. I'm Aaron Zeller, Director of Sales at SCC. Thank you for taking time out of your schedule today to join us. We really appreciate it. I will be moderating the webinar today. Your presenter and subject matter expert is my colleague Scott Fogel. Scott is the Senior Sales Engineer on our industrial sales team and is the leading expert in North America on the LME7 control.
Thanks, Aaron. Hello, everyone. Excited that we can get together today. This is actually an international webinar with much of North America present here, including folks from Canada and Mexico. We have some really nice content to go over to make everyone more familiar with this flame safeguard. Our goal today is to understand the LME7 flame safeguard. This training will help keep all of us safe and will provide confidence in working with this flame safeguard. Let's get started. First off, a little housekeeping. Click on the orange arrow will bring you to the webinar dashboard. If you have a question, feel free to send it here. At the end of the webinar, we will have a live Q&A session where we will answer the questions submitted here. If you have a question during the webinar, you can type it in and we'll try to give you an immediate reply. The agenda today is going to follow along with the LME7 technical instructions shown here. The spiral bound technical instructions will be a good reference. If you don't have the book, we have the electronic version available in the handout section of the webinar dashboard for you to follow along. Also in the handouts is a copy of this presentation and an LME7 drawing we'll touch on later. All of the sections of the LME7 technical instructions are shown here. We will start with the overview. We won't go through all of the sections. Instead, we're going to focus on select sections for understanding this flame safeguard. What does this flame safeguard do? The main purpose of this device is to open up the fuel shutoff valves and verify there is a presence of a flame. If there is flame, we know the fuel is burned in a controlled manner. If the fuel valves are open and there is no flame, we don't know where the fuel is going. Worst case, fuel is being dumped into an enclosed atmosphere, which is a recipe for an explosion. This flame safeguard's #1 job is to prevent any such explosion. This device falls under the category of the burner management system, which is described in NFPA 86 2019. NFPA 86 is the application standard for ovens, furnaces, and other industrial processing of materials. We will show how these safety interlocks are used on the LME7 flame safeguard. These interlocks are connected to the flame safeguard and are intended to maintain safe operating conditions. These interlocks are also used in other standards, CSA for Canada, CE for Europe, and even AGA for Australia. This LME7 flame safeguard is capable of being compliant with each of those standards around the world. It is made up of 3 components. The base unit, or the chassis of the flame safeguard. Program module, I like to call this component the brain of the unit. plug-in terminals that you see on the side of the unit. For reference to the LME7 technical instructions throughout this presentation, see the top right corner for the section and page numbers. There are 3 LME7 bases, all with different capabilities. Commonly, we call these bases LME71, LME73, and LME75. I call the program module the brain because it handles the sequencing, functions of the terminals, and the storage of the settings. The program module has configurable parameters to customize your application. The part numbers of the program module start with PME on the left that we can see there. You can tell the program module compatibility with the base unit by their part numbers. 71, 73, 75 are the numbers of the base unit and the program module. This table is helpful for selecting what you need for your application. I recommend to start at the top of the list with PME 71.111 with the LME 71. If this model doesn't meet your needs, start working your way down the list. Common reasons to work down the list are controlling an actuator, need self-checking scanner, or valve proving, just to name a couple. The last component of the flame safeguard is the plug set. These terminal plugs are keyed, so there's only one way they're being installed on the unit. In the event you have to replace an LME7 base, you can pop off the terminals with the wires on them, mount the new LME7 base, plug back in the old terminals. You could do the same thing with the program module. Take out the original program module with all your settings stored in it, plug into the new base, and you're off and running. For convenience, we have packages that include all 3 of these components in one part number. Example of an assembly part number is shown here. First section of the part number is the base unit. Second section specifies the program module. The PKG stands for package, which includes the plug set. A list of packages are shown here. Having one part number with these 3 components is helpful for ordering. The remote display, called the AZO, has 2 purposes. To configure a parameter on the LME7, the safety parameters of this unit are password protected for obvious security reasons. And to act as a remote display mounted on the outside of the panel for easy access to information. Don't forget the cable that connects the remote display to the LME7 base. This part number is TDC combo, shown here. This remote display is helpful as a service tool. I recommend service technicians to keep this tool in your bag for making parameter changes to the LME7. For applications with a PLC, the LME7 can communicate via Modbus RTU RS485 serial. This device will communicate essentially anything the LME7 knows. For example, flame signal strength, the phase of the program sequence, statuses of all the inputs and outputs, and first out alarm enunciation. For a complete list of addresses, check out section 8 of the technical instructions of all that it can communicate. LME73 and LME75 can control a Siemens actuator. Two Siemens actuators are shown here. I recommend to start with the SQM4. The SQM5, also shown here, is helpful for higher torque applications. SQM4 can go up to 160 inch-pounds. SQM5 can go up to 400 inch-pounds. Pairing the LME7 to the Siemens actuator is helpful for package burners and when the burner is using a ratio regulator. The reason why is that these types of systems are air leading systems that need the actuator to drive open for purge and drive low for ignition. When the LME7 is paired to the actuator, the LME7 drives and proves the actuator for purging and ignition using closed loop control. We'll show an example of this later. The LME7 platform can handle 4 types of flame detection. Flame rod. These are generally supplied by the burner manufacturer because there will be an optimum length associated with each burner. A UV scanner. These first two are most common for flame detection, flame rod and UV scanner. Self-checking UV scanner. Self-checking infrared scanner. The self-checking scanners are intended for continuous applications, which is generally understood as operating more than 24 hours. There are a few accessories that come with these flame detectors. In these pictures, I pick on the self-checking UV scanner, the QRA75. These accessories include a cable, mounting block, conductive thermal protection, and convective thermal protection. These accessories are shown on pages 6, 7, and 8 in section 1 of the technical instructions, if you'd like to see more. Some applications prefer to have the flame safeguard unit right near the burner to either minimize wiring runs or even ease of accessibility, whatever the reason may be. Putting the LME7 in a simple enclosure is an effective solution. A nice thing about this enclosure that I like is that the phase and fault code sticker is right on the enclosure. We will talk more about this phase and fault sticker later on. It is very helpful for troubleshooting and understanding what the LME7 is doing. SCC has available training demos. For additional on-site training, we can bring these demos and present to your team if you would like. Another option for training is if your company would like to purchase the demo for readily available option. Having the demo is helpful for new hire training programs. We are now going to look into the differences between LME71, LME73, and LME75. Let's start with the LME71. We are back to the program module table for selecting a model for your application. Identified here is our most common flame safeguard, PME71.111A1 with the LME71 base. Here is the wiring diagram for the model we've just selected. Each terminal has its designation. We have zoomed in on terminal X304. Each terminal has its own set of pins. Throughout the literature, we will see the nomenclature of the terminal plug followed by the pin. Example, terminal X304 period 5 is terminal X304 pin 5. Line, neutral, and ground are wired into X304. An external fuse is required on the LME7 units. The required fuse needs to be 6.3 amps or less. There are fusible links inside the LME7 to protect from hazard. If any of these internal fusible links pop, the LME7 base will need to be replaced. An external fuse is a good way to protect the unit. We will have a look at the input safety interlocks. This unit can handle a flame rod or a UV scanner. All we have to do is wire in the appropriate flame detector. The LME7 cannot handle both flame detectors simultaneously. One scenario where two flame detectors can be used is for a piloted line burner over 3 feet long. With a timing relay, the two detectors prove propagation of the flame. The first detector proves the pilot, and the second detector is located at the end of the burner to prove flame propagation. More information on two flame detectors is found in the appendix. For interlocks that have to be made all the time, we have the safety loop. We call it a safety loop because the interlocks must be wired into terminal X304 pins 1 and 2. The power has to come from the LME7 through the interlocks and back into the LME7. The high temperature limit is commonly included on the safety loop. Other customer interlocks also can go in the safety loop. These customer interlocks can be a door being closed, a conveyor running, any contact that has to be made essentially all the time, where if it opens, it immediately shuts down. Proof of closure is wired individually into the LME7. Low air pressure switch is also wired in separately. Low and high gas pressure switches are put in series and wired in. The proof of closure, air pressure switch, and gas pressure switches can all come from line and into the LME7 as shown on this diagram. In order to start the burner, we will need power on X503 pin 1. Generally, there's a burner on-off switch or a set of contacts from a PLC here. Remote reset is built into this unit. Install a reset button that connects to neutral. This input is a bit unique, being that it's a neutral input and not a line input. Let's have a look at the outputs. Pilot valve output is wired in here. Both main valves are wired right below the pilot valves. There is an extra terminal for the main valves that could be used for a burner on light. The main valves and the burner on terminal are energized at the same time. For direct spark ignition application, all that is needed is to install a jumper between the pilot output and the main valve's output. Ignition transformer output shown here. Alarm output is here in the corner. The LME7 can energize the combustion blower motor starter if needed. If the LME7 is not controlling the blower and there's still an air pressure switch, you will need the following jumper, labeled as Diamond 4. The reason for this jumper is that certain standards require to test the air pressure switch in the no-flow state. To comply with this standard, we use the blower motor output as the power behind the air pressure switch. We will see this later on in the phase diagram. When applying the LME7, you don't have to use all the inputs and outputs. The LME7 is versatile enough where you can use as little or as much as you need. We focused here on a single burner application. The LME7 can be used in multi-burner applications. If you go to the handouts portion of the webinar dashboard, you'll see a drawing of a multi-burner application using the LME7. A multi-burner application is a good example of not using all the inputs. If an input is not needed, it can be jumpered out. We are now going to have a look into the parameters. The parameters are broken into levels shown here. Don't worry, there aren't as many parameters as it seems. The commonly adjusted parameters are in the 100 and 200 level. Section 100 is helpful for some information, and section 200 is where all the burner safety parameters are. The 200 section is the most useful. The one parameter in the 100 level that we will look at here is parameter 140. This parameter determines what is shown on the built-in display. The default setting is 1, which identifies the phase. I recommend the setting 2. You'll still get the phase information, with the exception of when in operation, it will show the flame signal strength instead of reading OP1, which is the operation phase. Flame signal strength is shown as a percentage. Knowing the flame signal strength of a flame rod is particularly helpful. Commonly, as the burner modulates, you can see the flame signal strength decrease as you go to low fire. Knowing this percentage is very helpful, particularly when tuning low fire with a flame rod. Later on, we'll talk about how you can look at the flame signal strength during the pilot phase, which is helpful for tuning the pilot. The 200 level is where all the safety parameters are. In the literature, the shaded parameter numbers are the common ones. Several of the shaded parameters are shown here. Many of these settings are timings: pre-purge time, pilot and main overlap time, post-purge, and trial for ignition. Log into the unit with the password and customize your application. If your company wants the same configuration every time, SCC offers the service of setting up a unique part number for you. And right from the box, the settings are the way you like it. We don't charge extra for configuring the unit either. The other common parameter is an interrupted or intermittent pilot, with parameter 247. Select 0 for interrupted or 1 for intermittent. That easy. The flame failure response time is adjustable. There is a binary selection of 1 or 3 seconds flame failure response time. Here in North America, 3-second flame failure response time is very common. In Europe, for example, they require a 1-second flame failure response time. The parameters with timings are associated with a phase. Pre-purge phase 30, overlap phase 50, post-purge phase 74, and trial for ignition phase 40. Shown here is the phase diagram of the model we're looking at. At the top, you'll see the phase numbers and the description of that phase. Right below the phase numbers is a row for the parameters. These parameters show the timing of that phase. For example, parameter 225 is the pre-purge time for phase 30. Also, parameter 257 is the trial for ignition timing for phase 40. Both very commonly adjusted parameters. On the left side is a list of the outputs and inputs of the unit. At the bottom is a legend to indicate what the LME7 is looking for or what the LME7 is doing. The shaded blue is when power is present, and the X is when there is not power present. A blank box means the LME7 doesn't care, and the M is there must be power at the end of the phase. The heart of the operation of the LME7 is opening the shutoff valves and detecting flame. Here, we can see the sequence of the transformer coming on with the pilot valves. Once the transformer is de-energized, this is where a flame signal needs to be present. The rest of the sequence is the pilots lighting the main. The pilot valve output has 2 rows. Both of these rows have parameter 247. 247 being 0 is an interrupted pilot, and 247 being 1 is an intermittent pilot. It's nice to see the effect of the parameter change here in the phase diagram. Earlier, we talked about checking the air pressure switch in the no-flow state. We see on the air pressure switch input, there is an X in phase 21. If there is power on the air pressure switch at that time, the unit will go into an alarm. Phase 21 is checking the no-flow state of the air pressure switch. This check prevents a local jumper across the air pressure switch. If the LME7 is not controlling the blower, we use the blower motor output as the power source for the air pressure switch. Looking at this diagram, we can now understand how that works. Let's now have a look at the LME73. With the LME73, the added features from the LME71 are controlling the Siemens actuator and valve proofing. Here is the wiring diagram of the LME73 with program module PME73.811. We now see a Siemens actuator is wired into the LME7. The LME7 has closed loop control of this actuator. The analog signal is now wired into the LME73 instead of being wired directly into the actuator. When the LME73 is going through its phase sequence, it ignores this analog signal and drives high for purge and low for ignition as it needs to. When in operation, LME73 takes the analog signal and uses voltage to drive the actuator open and closed to a desired position. To make it closed loop control, the actuator provides a 0 to 1,000 ohm potentiometer feedback to the LME73 to verify the actuator position. If the LME73 does not get the position feedback it needs, the LME73 will go into alarm because the actuator is not in a position that it should. Because of valve proving, we now split the main valves into V1 and V2. The leak test pressure switch is installed in between the two valves. When we look at the phase diagram, we will see how splitting V1 and V2 is needed for valve proving. On this model, ignition position is equal to low fire. If you're looking at the technical instructions, if you go to the next page, you'll see the wiring of PME73.812. That model is able to have independent ignition position, which is sometimes helpful to light more reliably rather than having to light at low fire. Here are just a few of the parameters that I'd like to highlight for the LME73. Valve proving can be activated or deactivated with these parameters. There is also flexibility of valve proving at shutdown, startup, or both. The actuator can be disabled with parameter 515.01. Be aware that there are only some program modules that can disable the actuator. On the program module selection table, one of the columns identifies if an actuator can be disabled. The LME73 can accept different signals. 4 to 20 is most common. It could also accept 0 to 10 volts, 0 to 135 ohm, or even 3 position, also called full bump, using line voltage. Here is the phase diagram of the LME73.811. The valve proving sequence is shown on the far right. The phases for valve proving are phase 80, 81, 82, and 83. The 4 phases consists of energizing one shutoff valve at a time and monitoring the pressure switch in between the 2 shutoff valves. Phase 80 energizes V2, which results to atmospheric pressure in between the shutoff valves. Phase 81 closes V2 and waits to see if pressure builds up, which means V1 is leaking. Phase 82 opens V1, which introduces gas in between the 2 valves. Phase 83 closes V1 and waits to see if pressure drops in between the valves. If the pressure drops, this means V2 is leaking. Valve proving is nice that it checks for valve leaking every time the burner starts or stops. The rows on the bottom show the actuator controls. The LME73 starts off by fully closing the actuator in phase 21. Then the actuator drives high for purge. Going from fully closed to fully open, the LME7 is able to calibrate the range of the actuator. After purge, the actuator drives to ignition position for light off. Once in operation, the LME73 then drives the actuator according to the analog signal. Last model we'll touch on is the LME75. We're going to look at program module PME75.811. The main addition this model offers is that it can accept a self-checking UV scanner or a self-checking infrared scanner. Earlier, we talked about how only certain models you are able to disable the actuator control. With the LME75 program modules, we are able to disable the actuator if needed. Here is a very similar wiring diagram that we previously looked at. The LME7 platform is generally consistent with the terminal arrangement from model to model. We see the wiring indication of the self-checking UV scanner in the infrared scanner. For the self-checking UV scanner, there is a cable that's required with the scanner. The cable length is 12 feet long. A terminal strip or wire nuts can be used to extend these wires up to 300 feet. There are two new parameters that I'd like to cover. The LME75 can handle two flame detectors simultaneously. The two flame detectors are a self-checking UV scanner and a flame rod. It cannot handle two self-checking scanners at the same time. When using a flame rod and a self-checking UV scanner, there is logic for only one flame detector has to see flame, see or logic. The other logic is where both flame detectors have to see flame, see and logic. We are able to control the shutter time of the self-checking scanner between 5 seconds or 5 minutes. The idea is that every moving part has a cycle life. Using the shutter mechanism less often could increase the life of the shutter. The LME75 has been able to obtain approvals with this 5-minute shutter time. UL, FM, CSA, and CE. Here is a zoomed in look of the self-checking UV scanner. Looking at the zoomed in area, we see the gray outer tube and the bronze inner shield. This inner shield is what shutters like your eyelid. It will temporarily block the UV light and look for a change in state. If the shutter blocks the UV light and doesn't see a change in state, the UV scanner has failed on and the LME7 will go into alarm. Just for consistency here, here's the phase diagram of the LME7 at LME75. We have mostly covered all of its features in the previous versions, so we'll just mention it here. We are almost ready to start up the burner. We are now at commissioning. First thing to tackle is wiring the unit. We have addressed the wiring so we can move forward. Let's use the remote display to log into the LME7. With the webinar here, we're not able to get everyone a unit to play with. So I'm just going to briefly go through the sequence so you can get a feel for navigating with the remote display, and later on you could use this presentation to commission the burner. First step, press and hold the F and A buttons until you see code. Then use the plus and minus arrows to toggle between the letters and numbers. Once on the letter or number needed for the password, press the far right enter button. Keep using the arrow buttons and enter button for the entire password. Once your password is entered, hit enter one more time to log in. Now that we're logged in, next up is configuring the parameters. After logging in, you will first see the triple zero level. You can now use the arrows plus and minus to change to the desired level. Most commonly here is the 200 level because of all the burner safety parameters that are there. You then press enter on the desired level. You can then use the plus and minus to select the parameters that you need. Once you found your parameter, press enter to dive further into that parameter to try and change it. You can then use the plus and minus arrows to change the parameter. Once you've changed the parameter, you can then hit enter. When you change the parameter, the setting will shift to the right and stop blinking. This is a good indication that you have changed the parameter. To go back, tap both the plus and minus at the same time. It is labeled escape on the remote display. The main takeaway here is that hitting enter button dives you further in, and tapping escape has you go backwards. Once you change a couple parameters, it'll feel much more natural. Now that we've logged in and configured the parameters, I suggest doing a backup. I describe a backup as hitting save on your work, kind of like an Excel spreadsheet or a Word document. Doing a backup saves the parameter set to the program module. This is particularly helpful if you need to replace the LME7 base. You can use the original program module to install in the new base, and you'll have all of your settings. One way to back up the configuration is to press and hold the plus and minus on the unit for a couple of seconds. You will then see RST. RST does not stand for reset. RST in this case actually stands for restore. A restore is when the parameters in the program module are downloaded to the base. A backup is taking the parameter set in the base that we've just changed and saving a copy in the program module. Backup and restore are reverse operations of each other. Go ahead and press the plus button to have the display read BAC. This is our backup. Press and hold the far right enter button until you see run. After the display shows run, it will then flash BAC and then end. This is a good indication your backup is complete and you've saved your work. If you would like SCC to do steps 2 through 4, give us a parameter set and we will deliver the same configuration to you every time right out of the box. We are now ready to start up the burner. Before we look at a short video of the startup, I wanted to show the sticker that comes with every LME7. There are 2 sets of information on this sticker. What the phase diagram means, what the phase numbers mean, and what the fault codes mean. I recommend to place this sticker as close as you can to the built-in display. Knowing this information on the sticker is particularly handy for troubleshooting. Here is a short video showing a startup sequence.
As an example, let's start up the LME7 so we can go through a complete startup sequence. Phase 21, phase 22, the blower being energized. Now, P30, phase 30 is pre-purge. Phase 40 is your trial for ignition, your ignition and your pilot. Your ignition turned off, pilot is on, phase 44. Phase 50, overlap of the pilot and the main. Phase 52, mains by itself. We are now in operation. Now we see flame signal strength from 0 to 100%.
All right, the next section is PWM blowers. We're actually going to pass on reviewing applications with PWM blowers. There's quite a bit of information on controlling a PWM blower. We couldn't be as thorough as we would want in this webinar format. For reference, PWM stands for pulse width modulation. PWM is a means of controlling the speed of the blower. Similar in concept to a variable frequency drive. Instead of frequency though, PWM uses variable voltage pulses. If you would like more training on controlling a PWM blower, send a quick email to marketing@scccombustion.com, or you can contact your SCC account manager. We will get you information and provide you additional training as needed. The last section we're going to cover is troubleshooting. When the unit is in alarm, the LED will turn solid red and you will see LOC and then a number. This number is a fault code. To see what's going wrong, there are a couple resources that you could use. One is the sticker, is a very helpful reference. Having the sticker very close to the burner, you could look up what a lock to means. And in this case, lock to is an example of no flame at startup. Another resource is the technical instructions. The technical instructions provide a little more detail by giving you corrective action. For the example of no flame at startup, there's a list of things to look at. Do I have spark? Are valves opening? Verifying air-fuel ratio, etc., of the things that it takes to light the burner. Earlier, we looked at how the safety input interlocks were wired separately into the LME7. The benefit of wiring in separately is now the LME7 can tell what has caused the alarm. Some of the interlocks even have multiple alarms, like flame detector. Lock 2, for example, has never got a flame. Lock 4 is there's a flame when there shouldn't be. And lock 7 is a loss of flame during operation. Air pressure switch also has 2. Lock 3 is the air switch is open, while a lock 5 is the air pressure switch is closed when it should be open. A lock 5 is the pressure switch is made in the no flow state that we had talked about earlier. The valve proving fault codes have lock 12 and 13. What's nice about this is this can tell you whether it was V1 or V2 that is leaking if valve proving has failed. Earlier, we talked about how the remote display is a good service tool to keep in your bag. One reason to have a remote display is to have a look at the flame signal strength at any time. To do this, press the far right button until SER appears. SER stands for service. Once you see SER, you can release. You could then use the plus and minus arrows to navigate to parameter 954. Parameter 954 is not something you can change here, but instead is a viewing only parameter. A little tip, a good use of this is when tuning a pilot. The display on the LME7 will show the phase and the remote display can show the flame signal strength. So you can get both pieces of information right at your fingertips. Another reason to have the remote display as a service tool is that you can see the history of the last 10 faults. You can get a feel for what kind of faults the unit has been getting before you even begin your work. To obtain the faults, it's the same procedure as the last slide. Press enter until SER appears, release. Then you can use the plus and minus arrows to look at past alarms. 702 being the most recent past alarm, where 711 is the 10th alarm in the past. There are 3 ways to reset an alarm. All 3 of them require a 2-second press. In reality, the window is between 1 and 3 seconds. So we shoot for 2 seconds and we should get it. If you just tap the reset button, it won't do anything. If you hold the reset button too long, it will go into diagnostic mode. Diagnostic mode doesn't affect operation and it doesn't have any purpose here. The first way is the far right button on the built-in display. This is the most common reset method. The far right button on the remote display is a reset button as well. The remote reset button is the third way. We have recently added a short YouTube video on troubleshooting the LME7. There's a copy of this presentation in the handout section of the webinar dashboard where the link is active. Feel free to just focus on troubleshooting. This video is a good explanation. That's all for the presentation portion of the webinar. If you need additional information about training, wiring diagram conversions, need some stickers, LME7 technical instruction books, or even a quote, feel free to contact your SCC account manager. Or if you're not sure who that account manager is, you can always send an email to marketing@scccombustion.com. Let's bring back Aaron on for a live Q&A session.
All right, Scott, thank you very much. That was very thorough and covered quite a bit about the LME. We did have a few questions come in during the presentation, so I've compiled a few of them here, and let's get started. Reminder to anybody, if we do not get a chance to answer your question, we will reach back out to you via email or personally via phone in the next day or so to take care of the answers to your questions. So Scott, the first one is you had mentioned an LME7 multi-burner drawing and arrangement. I don't see that drawing in the handout section. How would this be done?
Yes. So I originally tried to include it in the handouts. We will try to get a copy of that drawing to the group here. But I'll briefly talk about that drawing. It's essentially a 10-burner system, all working in a 1 down, 1 out arrangement. And one of the key things that it shows is a lot of the inputs are actually disabled because some of the interlocks are common to the system, rather than being all 10 burners. So it's a case of kind of stripping down the LME7 and using as needed. And the example shows a 1 down, 1 out scenario. It can also be used in a 1 down, all out scenario. So it does have flexibility for depending on the application.
Okay, very good. Moving on here, the next one was, it looked like there were several types of PMEs, and there were 4 that you discussed primarily. How would I select which one I need?
So the PMEs, the best way to select a program module is certainly by the table that we had showed before. That's kind of the PMEs on the left side of that table, and the top, the different features. I recommend starting with kind of the top, which is PME 71.111. That's our base flame safeguard, our most common. And then if that doesn't meet your needs, I suggest to work down the program modules to see what fits your application. So that's the recommended procedure that I would have for you guys.
Okay, and there were differences there about flame scanners and so forth, I believe, right? Like continuous operation versus standard self-check and things, and that depends a little bit on the LME and PME combo you talked about?
That is correct. So depending on if you have a flame rod or UV scanner or self-checking scanner or self-checking IR, any one of those 4 selections will have will determine what program module that you need.
Gotcha. Okay, very good. And as a guy on the sales team, I was happy to see this question. Are these flame safeguard units readily available?
Yeah, I'm with you. Yes, they are. We certainly have a lot of good news to present on that front. Of we typically, LME7 being a very common product for us, we keep several months, of supply. The only I would caution is if you do have an application with 220 volt, 220 volt just isn't as common as say 110. So our inventory levels aren't as high. So I would ask, hey, give us some time on your 220 application. Where if it's a 110 application, it's going to be 2 to 3 days lead time is what I would expect.
Okay. Let's see, a couple more here. All right, how about this? When plugging in a new program module, the PME, does the LME7 ask to be backed up or reset, or what is required in that circumstance?
Yes. So when you do plug in the program module and then give power to it, it's going to flash PRC RST. So what it's doing, what that is kind of telling you is that it wants to be restored. And that restore process, essentially the parameters in the program module being downloaded into the new base. And so what you would do is you can do the far right enter button after you install the program module and just press that. And I believe it's about 2 seconds. And then the unit will show run. And then it'll be a restore end, which will show a lock 138, which is a fault code. But in this case, it's not really a fault code. It's more of an indication that you have downloaded a new program module. And then once you reset a lock 138, your display will show off and you're up and running.
Okay, very good. The next question specifically was about the safety loop, but I'm going to add just a little bit. If the safety loop is tripped, or any of the other safeties you talked about, right, gas pressure switches or air pressure switch, if those are tripped, does this require a manual reset at the LME?
So if any alarm has occurred, it does require a reset. And the reset we had briefly touched on is those 3 approaches. One of them is at the LME. The other reset is the remote display. And the third reset is the remote reset button that can be wired in. So if the unit goes, if the safety loop is tripped, unit goes into alarm, it absolutely is required to one of those 3 reset methods.
Okay, very good. There's 2 more here I like that I think are, in fact, one of them was asked a few different times. So we'll start with the first easy one.
Okay.
Minimum flame signal strength. You talked a little bit about being able to see the flame signal strength. What's the minimum strength required to keep the relay happy?
Yes, I believe the book answer is somewhere, I believe about 20%. But actually, in reality, if you're somewhere around the 35, 40, or 50, you're really on the ragged edge. Actually, generally the signal gets a little bit more erratic when it gets that low. So yes, the threshold is 20, but I would say if your flame signal is really jumping a lot and say like the 30s, 40s, and 50s, I wouldn't feel too comfortable with that because your burner's holding on, your flame detector's holding on.
Yeah, I think that's a good point, Scott. I'd like to add just a little bit to that in that
Sure.
Siemens flame sensors, we talked about QRA, the UV scanners, and a QRI IR scanner. And of course, the LME works with a flame rod. The LME has a very robust flame sensing circuit built into it. So to echo Scott's point, if the flame signal is as low as 30 or 40%, there's probably something quite wrong with the burner. It's probably barely holding on to an actual flame, or the scanner is in a bad place where it can barely see the flame or sense the flame. In our experience, flame sensing on an LME is rarely a challenge. Certainly with a burner that has a robust flame, there's no difficulty whatsoever in sensing it with any of our scanner options. All right, and the last question that I'm going to take this one, Scott, if you don't mind. There were about 3 or 4 people asked about this, if there would be a recording of this presentation, and if so, would it be made available, and so on and so forth. So the answer to that is yes. The webinar platform we're using automatically records this, including our question and answer session that we're doing right now, and it will be provided on our YouTube page, our YouTube channel rather. I don't know exactly when, but it should be by early next week. So keep your eyes open for that. If you guys are not already subscribed to our YouTube channel, if you go to YouTube and search SCC Inc., there are 3 of them, I believe, that show up under that name, but it's pretty easy to differentiate us from the others. And we currently have about 7 or 8 videos there. We will have all of the webinars we do will be posted there shortly after they're recorded and completed. So I think that's about all the time we've got for today, folks. Thanks again for joining us. I really appreciate that. If you have additional questions that you did not submit, or if you think of something later, say later on today, you think of something that you would like to ask us, please don't hesitate to contact us directly through your account manager, or as Scott mentioned earlier, if you don't know who that is, send an email to marketing@scccombustion.com, where we'll be monitoring that and either distributing it to the right guys or getting back to you directly from there. Also, please keep your eyes open for upcoming webinars over the next several weeks. We've got a couple planned. In fact, we already have one planned next Thursday and the Thursday after. We'll be covering things like gas trains, control valves and actuators, and other combustion control topics. To ensure that you receive information on these topics, please add marketing@scccombustion.com to the safe sender list in your email settings. That makes sure that things get in. And if you don't want to register, that's fine. You can delete it, but that way you at least know when they're coming along. Also, given the fact that these are all recorded, if we're doing a webinar that you cannot attend due to your schedule, but you register anyway, you'll automatically be sent a link to the video when this is done. So that's a good thing to keep in mind. So with that, thank you all again for joining us today. Thank you to Scott for hosting and for running this, and sure appreciate it.
And yeah, just to reiterate, yeah, thanks for spending time with us this morning, and have a safe day. Bye, guys.